This is Algebra 1, Semester 1, Unit 1, Section 1.6. In this section, we're looking at domain and range. Domain and range are so much fun to figure out. Here's what I do. Now, don't think that this is really how I feel, but it helps you to remember relationships and functions. In a function or a relationship, anytime you look at ordered pairs of numbers, you have x first and then y. Now, I think of x as being the man. In math, we don't like to have such slang as that, so we call him domain. A little more proper. Now, one thing about the man or domain is that he's very independent. He likes to lead. He's in this couple situation, but really he's the leader. He's always in the lead. Now, the y happens to be called the range. And she is very dependent. She follows him everywhere he goes. Anytime they show up, she's behind him in the partner. Okay? Again, don't think that I really feel this way about couples, but if you think of the pairs as being a couple, he's in the lead, he's the domain, he's the x, he's independent. She's the range, she's always coming behind, she's the y, she's very dependent. Now, let's talk about how you write these down below when it asks for that. The x is your domain. You simply take the numbers and put them in order. They happen to be listed there in order. Oftentimes they will be on a domain. Never repeat a number twice if one's repeated. Now in the range, it's the y. It also happens to be in order here, 4, 6, and 8. Now let me give you a sample of a map. The way that you would do a map is if you had the ordered pairs 1, 3, 2, 1, and let's say -4, 6. You would take the smallest, or I shouldn't say smallest, the least of the domains first. Now the domain's only the leader, and that would be the -4. You take the next biggest domain, that would be 1. The next biggest would be 2. That's your x. X is usually always put on the left-hand side. With range, that's your y. She follows. We have 6, 1, and 3. We put the lowest or the least first, 1, and then 3, and then 6. Now with a map, we connect with a line who the partners are. So 1 is with 3, 2 is with 1, and -4 is with 6. Okay, down here we would list them. The nice thing off of a map is when you take them off the map, you can just list them right in the order from the map because it's always put in order. So -4, 1, 2, and 1, 3, 6. Okay, with the domain and range over here, again, the first one is your domain. Your smallest of those is -4. The next would be -3, and I shouldn't say smallest, they're the least. And then the next one would be the -2, and the last one is 9. Now the range are the ones that follow. You have 6, 8, 5, and 6. 5 being the smallest. Least. I'm so sorry. By the way, that's a typo there. It shouldn't be 9.5. It should be a 9,5. 5 being the least. Next would be your 6. Don't write it twice, only once. And then the last one would be your 8. That's how you write the domain and range. Now, here they're wanting us to define whether or not it's a function. And I just look at it again like a couple, and I say, well, is the X cheating? Because we all know if a guy cheats in the relationship, it's not going to function. So let's look over here at these pairs first. In the pairs, let's identify our guys. I just take a highlighter and I identified the man. Domain is -3, domain -4, 9, and -3. I get suspicious here because I notice in the couples that I've got this guy that's -3. He's showing up twice, isn't he? So I need to look real close at that. That might cause it to not function if he's cheating. So we have to examine, well, he's showing up with 6 here. Oh, and he shows up with 6 there. So that's still a function because he is not cheating. So now we go to this next one. Okay, now we have a whole different group that we're looking at. Again, domain is -3, -4, 9, and -2. Do I see any of the domains or domain cheating? The domain seems to be not repeating with a different partner. So that is a function. So we go to the next one. Whoops, hit my camera. We don't want to set that off. Okay, now we go to the next one and we see that the man is -1, -4, 9, and -2. So we ask ourselves, is anybody cheating there? Well, none of the domains or domains are cheating. So that's a function. Now we go down to some ordered pairs where there might be a different story. Take a look at this one. We highlight our man in front, -3, -4, 9, and -3 is showing up twice. Is he cheating? He's with the partner 6 here and the partner 7 there. That is not a function. I don't have room to write function out there, but that is not a function because that -3 is appearing with 2 different partners. So now we look at the next one. Again, I spot -3 in this one, showing up with 2 different partners. So that's not a function. The last one here, I see a -1, a +1, well, those 2 aren't the same number, a -4, so far we're so good. Oh, and then -4 shows up again. Is he cheating with a different partner? Yes, he is. He's here with an 8, here with a 7. That is not a function. In mapping, if you have a function, let's just map one of these. In fact, let's map this middle one. We have the least of the domain is -4. The next least is -3. The next would be -2. And the greatest would be 9. The only y value is 6. So all of these are partnering with 6. That is a function because in mapping we look to see if any of the domains have 2 lines. None of the domains do, so that works out well. It's still a function. Now we'll take one of these and put it in the T-chart. It would go -4, 6. We'll just take this one, -3, 6, -2, 6, and 9, 6. That's how you read it out of the T-chart. Okay. Now we come down to what was not a function. Let's look at how not a function maps out. We'll take, let's take this one. -4 is our least of the domain. Then we have -3. Do not write -3 twice, we only write it once. And then we have 9. Over here on the y value, we have 1 first, it's the least, and then we have 6. Now we match up our line, -3 with 6, -4 with 6, 9 with 6, and -3 with 1. Now the only line there that causes this to not be a function is this one right here. Right here, we have 2 lines going to the 3. That's the only part that causes it to not be a function, is when we have 2 lines going to one of the domain. Doesn't matter that we have multiple lines to the range. That doesn't affect whether or not it's a function. Okay, how this looks in the input-output table, we would have -4, 6, -3, 1, -3, 6, and 9, 6. So you can see here that in the input-output table, you do repeat a y or an x value because they have to be partnered up. Next thing that we're supposed to do is to make a table for the function y equals 2x minus 5 for the values 10, 12, 15, 18, and 20. So we literally have to plug these in to calculate our x, or calculate our y value. You plug them in for the x. 2 times 10 is 20, minus 5 is 15. There's your y value. So you come over to your T-chart that's written horizontally and you put 10 is with 15. They are now partners. 12 plugged in for x. 2 times 12 is 24, minus 5 is 19. 12 and 19 are partners. 2 times 15 minus 5. 2 times 15 is 30. Minus 5 is 25. Two times 18 minus 5. 2 times 18 is 36, minus 5 is 31. And 2 times 20 is 40, minus 5 is 35. So those are simply evaluating in a T-chart format. Here they're wanting us to find the function rule. This is kind of like the function munchkin game that we've been playing in class. So we're trying to figure out what is going on here to cause this outcome. Well, we see right here that at 0 we have 8. Remember from the game, that means that we're adding 8. And you can write that on every line because we remember it's the same rule for every line. We're doing the same thing. So now we look at it and we say, well, what do we add to 8 to get to 10? That would be 2. What do we add to 0 to get to 8? Well, nothing. What do we add to 8 to get to 7? Well, you would have to subtract 1 to get to 7, wouldn't you? And what would we be adding to 8 to get to 6? It would be a minus 2. Now I take these real light written numbers here And I realize I've got to multiply that -2 times something to get +2. That would be multiplied by a -1. That would give me a +2. Now I drop down to my next one. Would a -1 times -1 equal that 1? Yes, it would. So I bring that 1 in there. Would a -1 times this number equal -2? Yes, it would. So I go ahead and I bring this number in. Now I have my equation, because I can fill in -1 times 0 to follow the pattern. And now I look up here and I say all of these are my x values. That would be represented by x. -1 is a constant of occurrence, so I bring it into the equation. I have -1 times x plus 8. Pause that video and think that through. Look it back over if you need to. Again, here's what I do. Why? Please pause the video as you need to on these. Go to my 0 line. I'm adding 1 to 0 to get that 1. So I write +1 in all the lines. Now I ask myself, what do I need to add to 1 to get to -3? Well, I don't need to add anything. I need to subtract 4. What do I need to add to 1 to get to +3? Well, here I would need to add 2. What do I need to add to 1 to get to +5? That would be 4. Now I go back over and I say, how can I multiply -2 to get to -4? I could multiply it by 2, couldn't I? 2 times -2 is -4. So I'm going to put a 2 out front and write that -2 in there to show that's -4. What would I multiply 1 by to get +2? I would multiply it by 2 as well. So now I bring in that 1. So I'm replacing the 2 with 2 times 1. What would I multiply 2 by to get to 4? It would be 2 times 2. Now when I look at my whole column, I can fill in my 0. And I say the 1 is a constant. It comes up. This 2 occurs over and over, so it comes up. Inside the parentheses is my x values. The reason that we call it a variable is that these numbers are varying. So we put an x in there. Okay, example number 5. Make an input-output table that fits the situation and find the rule from it. You guys actually have real good street smarts on this, so we're going to just pretend that this is happening. We're buying concert tickets that cost $15 each. There's a $3 charge on every order. So let's make this number of tickets. And this is our total cost. If we buy 1 ticket, it's going to cost us $15 plus $3 for the order. So that'll come out to be $18. If we buy 2 tickets, we'd have to take 2 times that 15 and add $3 for the order, and we would get 33. If we bought 3 tickets, we'd be taking 3 times 15 plus $3 and we'd get 48. At this point, you could stop and look at your column, and we realize 3 is constant. It would come into the answer for the equation. 15 is occurring over and over. We don't call it a constant because it's connected with this variable. So 15. Now, we like to put the variable behind, so we're going to switch it over there. We'll just put t. We are adding them. So that's our final answer. 15 plus 3 is our expression. We do need to say what the t represents. T equals number of tickets. Thank you very much. That concludes 1.6.